Hey guys, this is Carl, and this is week 8, problem number 7. And so what we're going to do, just kind of talking about the null hypothesis and alternative hypothesis, and then we'll go ahead and get started with the question. An information technology analyst believes that they are losing customers on their website who find the checkout and purchase system too complicated. She adds one-click feature to the website to make it easier, but finds that only about 13% of the customers are using it. She decides to launch an ad awareness campaign to tell the customers about this new feature in the hope of increasing the percentage. She doesn't see much of a difference, so she hires a consultant to help her. This consultant selects a random sample of recent purchases, tests the hypothesis that the ads produce no change. What does that mean? No measurable effect, no observed difference. Against the alternative that the percentage of one-click feature is greater than 13%, that the ads did have a measurable effect. And this consultant found a p-value of 0.35. So which conclusion is appropriate? 35% chance that the ads worked, 65% chance that the ads worked. These two, they don't really get at, the p-value doesn't really determine this for you in a hypothesis test in terms of the success, chance of success. Because what is the success? That it's greater than 13%? It's really not what we're looking at. There's a 35% chance that the null hypothesis is true. No, it's starting to get at that, but that's not exactly what we're talking about. The actual correct answer is there's a 35% chance that the natural sampling variation could produce poll results like these if there's really no change in website use. So if there's no change in website use, which is definitive, that there's a 35% chance that this could produce poll results. So, so that's what we found, that this poll results being that greater than 13%. So she was figuring out whether or not this actually is 13%, is the null that it equals. So what is we looking at here? Natural sampling variation. So what that means is the variation in the sampling methods. You know, there could be study contaminants. There could be other in terms of regional demographics, those kinds of things. If for example, here in Baltimore, Maryland, if you're looking at the Upper West Side only when you're talking about Baltimore City health outcomes, it's not appropriate to just look at one side of the city. You want to actually get the whole city, sample the whole city. Now natural sampling variation. There could be a give or take variation in terms of the number of participants selected, say, in that kind of survey for Baltimore City, if there's in assessing health outcomes. But by and large, there should be enough equal dispersion of the sampling so that you can actually have a representative sample. That's where that term comes from, that the sample is representative of the area for which you are surveying, or in this case, the consumer base that you are surveying. That's really what we're getting at, that it's a true representative sample. So 35% chance that natural sample variation could produce poll results like this, that the p is greater than 13%. So this is our actual right answer. So if you have any questions, go ahead and let us know. Otherwise, thanks so much.